and welcome everybody. Congratulations for those of you who joined early and got to listen to the two Simons of Nim speaking about cables and football. It was very interesting, I hope. And welcome to this week's very exquisite community call. My guest today is, first of all, my partner in crime, who's always with me during these calls, is Ismail. Say hi to the people, please.
Hey everyone.
And then today with me, I also have Nim researcher Simon Wicky.
Hello, everyone.
Hey. And I think we're still going to give a few more minutes for people to join. We don't have as many people as we normally have, and then we'll get started with the news roundup. And this whole thing would be way less uncomfortable if only we had some elevator music.
Yeah, exactly. I want to thank, I forgot who it was, but someone recommended a bot to play some elevator music during the call. And yeah, this time I actually have an actual good excuse, which is that I was unable to set it up simply because of technical difficulties. So I promise each and every single one of you, I promise you all that next week there will be elevator music, and this time it's not a meme. or else all of you can blame me in the chat. It's all right.
Thanks, Sven, by the way, for providing the link to the elevator music bot. We'll hopefully Ismail can make it work by the next community call. All right, let's get started with the news. What do you have for us, Ismail?
Yeah, so a new blog was released about the new developer grants. So the new announcement is that NIM shipyard development grants have been released. So following the launch of the first set of shipyard service grants, NIM has now launched the next set of shipyard grants, and these grants are specifically for organized with developers in mind. So with these grants, NIM aims to support developers from a variety of projects, which would make it easy for people with coded proof of concepts or ideas to actually be rewarded for them. So the first round of the developer grant scheme opens up two different calls: the Vinch grant and the Briar grant. During this round, a maximum of 5 Vinch and 3 Briar grants will be selected. So in order to apply, please fill out the form listed at the bottom of the blog post that's being shared right now. On to you, Simon.
Exactly. And in other news, you may have missed it actually because we've only released a blog post, I believe, 1 or 2 hours ago. So we also released the NIM SDK, which is a TypeScript SDK to create apps that you can use that can use the NIM Mixnet and Coconut credentials quickly and efficiently. And basically, it allows you to send data over the Mixnet with ease from browser-based applications such as browser extensions, but also just regular websites. And we also created a demo. I believe a link to it was shared in the dedicated community called Text Channel. It's a very simple chat app that uses the Mixnet in any browser. And probably I butchered all of that, so maybe the other Simon wants to add something to my very bad explanation.
No, your explanation was actually really good.
Oh,
Nothing to
thank
add.
you.
Sorry.
All right, that's great stuff. I wasn't expecting that at all. So then moving on to our next news item. This is all Shipyard Academy related. So first of all, once again, congratulations for everybody who made it to stage 2. The competition was fierce. We have about 650, I believe, Nimsters. Congratulations to all of them. So uh, one of the key things that we announced in the blog post, but I will reiterate here, it's that we'll only have one quiz this stage, the second stage, which is going to take place next Sunday. This is because the next lecture with Claudia Diaz, our Tokenicon deep dive, is going to be on Friday instead of Thursday, and I want to make sure that everybody has enough time to look through the slides and watch the video and take in everything and maybe take some notes and stuff and prepare for the quiz. So for this reason, we're going to have the quizzes at the same time as before, but it's going to take place on Sunday instead of Saturday, and there's only going to be one of them. Yeah, and the other news about shipyard academies, we had a lecture, of course, yesterday, as always. And once again, I would like to point out the heroic effort that Max went through for for holding this lecture with incredibly bad allergy. So he's an absolute legend as always. The upload is still so I'm still editing the video because I'm overlaying the slide deck that Max used during the presentation, so that everybody has, even those who didn't catch the event live, have access to the actual slide deck along with the actual lecture as well. But I already shared the slide deck and some related older blog post, which explains the different types of nodes that make up the NIM mixnet. And by the way, the lecture was a deep dive into the NIM mixnet and the nodes that make it up, and also the technologies it employs. It's highly recommended, even for those of you who are not participating in Shipyard Academy. I believe it was by far the best general overview of our tech that I've heard so far. So even just going through it while editing the video is a huge experience, and even me, I'm learning while doing that. So it's highly recommended for everybody. Over to you, Ismail.
Thank you. So earlier this week, the NIM tokenomics update was released. I'll just give you a quick overview in case you haven't read the blog article yet. So let's start. Let's see. So the circulating supply of NIMs is now around 304 million NIM tokens. The staking supply is approximately 349 million NIM. The stake saturation point is now 726,000 NIM saturation per node. The ability to delegate, this is an important one, the ability to delegate unvested tokens is now capped at 10%. They did this to prevent whales from receiving the largest proportion of rewards by staking locked tokens. So this should ensure better rewards and also wider distribution among all stakeholders staking unlocked NIM tokens. And as an added effect, also ensures decentralization of staking power. So please do not forget to read the blog that Fornoos just shared in the chat, because it lists all details, and it's more of a deep dive into the actual tokenomics changes. And moving on. So
I will add something. I will
Oh
add
yeah.
something here real quick. So those of you who already delegated your lock tokens before the migration over to the new contract, those delegations remain delegated. So if you already delegated lock tokens, you may want to keep those delegations as they are and not change them until your tokens unlock. If you want to keep those tokens delegated, this is a pro tip. Go ahead, Ismail. Sorry for interrupting.
No, that's great. That's great. So our Ukrainian developer relations associate Yana presented NIM at the Internet Without Borders hackathon for Ukrainians and Russian exiles in France. So yeah, thank you for news. There's a picture shared, a tweet shared. Please check it out. Regarding the NIM team, they just want to thank all the hackers for building at the event. So let's move forward with Simon Wicky, our guest of the day.
Yeah, exactly. So, as many of you know, because I already talked about it in the first intro, and now I'm giving the second intro to this conversation, the number of Simons in this call went up by 100%, 2x. I think that's really, really nice in a bear market. So let's be grateful for that. And yes, I'm going to be making corny Simon jokes every single time the other Simon is on call. For those of you who don't know, I'm also called Simon, so this is where these amazing jokes are coming from. I hope everybody is having a good time with them. So yeah, welcome, Simon. It's awesome to finally have you back on. And for those of you, for those in the audience who are new and haven't been around for long, can you please introduce yourself? What do you do at NIM?
Of course. Hello, everyone. My name is Simon. I'm working the research in the research team as a research engineer, and basically I'm working mostly on the mixnet parts, which includes anonymity, parameters, a lot of stuff.
Oh wait, I forgot to tell people something, and it's that if you have any questions to Simon, either Simon actually, then make sure to leave them in the dedicated community call text channel, because we're keeping an eye on that, and we're going to be answering them if you have any. All right, so since we last talked, what have you been up to?
Well, since we last talked,
I mean,
what
wait,
was he doing when we last talked?
let's actually qualify that, because we talk every day privately, but since we last talked on one of these community calls.
Yeah. Well, I finished my proof of concept for implementing sender anonymity, which has been passed to the dev team, and he's slowly making its way through the releases. I don't know for when it is, but probably very soon. And right now, I'm moving on other stuff, which include another solution of sender anonymity, some redesigning of the cover traffic strategy, and try and fix some good parameters for the mixed net.
For those in the audience who don't know, can we quickly glance over sender anonymity?
Yeah. So the rough idea behind sender anonymity is to be able to talk to someone through the mixed net without them knowing exactly who you are. Like you can sign your message, but they won't be able to tell your actual address in the mixed net. And this is not something trivial to do. And so it took some time. There are some existing building blocks in the research, but as always, you have to take those blocks that exist in the nice theory world where all cows are sphere in a vacuum, and bring them down to our world in order to make them work. And you always have to do some little tweaks so that they are actually usable in the end.
All right, I see. And can you maybe also go over why it's not trivial to do sender anonymity?
Well, it's not trivial to do because I mean, how just think about it. If I want to talk, I'm sending you a letter with, like, let's say the post. How can you reply to me if you don't know my address? And so then you need to have some. Of course, you will have some encryption, but there's there's a lot of info. Basically, there's a lot of info that can leak almost everywhere, and you have to make sure that everything is tight. So it's complicated.
Oh yeah, okay, I understand. Well, I mean, that was just a quick glance over. For those
Yeah.
of you who are interested in a much deeper conversation about this topic specifically, I'm going to be sharing a link to our previous conversation with Simon, and then you can gorge your ears on that. But moving on, actually, because we've been conducting some pretty exciting testing that I've been really excited about. So for the past 3 days or so, I've been listening to music on Spotify over the Mixnet. I actually even downloaded my entire library on my laptop from or through Spotify in what Spotify calls very high quality, which I think is highly questionable. But anyways, so what is this testing for? And are we collecting any sort of data, or what's this supposed to serve?
Well, it's I'd say it's in two parts. The first is just to pump some traffic through the mixnet to see well, to bump up the numbers. But secondly, and most importantly, is to see if everything works, because when you code stuff, I mean, almost anything can happen, and when you're coding, you cannot think about everything. So you will still have some bugs, and that's why bugs reports are there. And the best way to find out bugs is to test the system to its limit. So he wants to run some proxies, to run some clients, to pump some traffic through his proxies, to really like torture the mixnet to see how it if it withstands the pressure, and if it does not, what can we do to fix that? Now, we're not really collecting real world data for anything, but it's just to test that the system works, and to be amazed at the fact that it works as well. Because when you can download your entire Spotify library through this mixnet, which looks and is really complicated, it's amazing to see that it works.
Well, tell me about it. I was also super excited to finally get to use it for stuff outside of NIM Connect. So it was really exciting. Now, actually, one of the most surprising things that you told me about the testing is that you conducted a video call as a test, which
Yes,
which apparently had zero issues, right? So you didn't even
multiple, yeah.
notice. That's pretty amazing. So my assumption, but of course I'm not really I don't have a very deep understanding of the tech, but my assumption was that due to how the mixnet works, and the number of nodes involved in getting a piece of data over to a different location, it would be kind of so one of the most latency sensitive applications of the mix that would be a video call, right, or any network. At least that's what I assumed. So for me, it's really surprising that that it worked very well. So how did that turn out to be?
It is surprising because, like you said, historically the mixnets are best for low latency application. But then now it's a different sort of mixnet which involve continuous time mixing, which makes it better for low latency application. I said wrongly before. Mixnet are better for high latency application, not low. Sorry about that. And in that case, well, it's just there's not that much delay within the mixnet. It's only 50 milliseconds per hop, and you already have some delay when talking like this on Keybase on Discord. Sorry. And if your flow is nicely behaved, if it's actually not a lot of traffic, and like it's streaming, so some packet loss is acceptable. You will maybe miss some of the audio and some stuff, but it's still fine. And maybe there was a little bit more delay than usual, but you just don't notice it. But it's actually amazing that it works.
Yeah, it is. It really is amazing. I would have expected something like video call to not work very well until further optimization. So that sounds very nice.
But then it all boils down at the end to the bandwidth that you can have, and with the proper settings, you can actually have a more than decent bandwidth, which is more than enough for a video call or a voice call, which is actually surprisingly low in bandwidth.
Compression is real when it comes to these solutions for video calls. They have been I mean, especially during COVID, development of such technologies skyrocketed. You know, the resources that was put into that. And actually, when it comes to download speed, we have a question from George, our old friend. What's the download speed of the mixnet? So how much slower is it than regular Wi-Fi or regular internet?
It's hard to say because the final parameters are not set yet. By parameters, I mean packet size, mainly packet size and sending rate. So I cannot give you a final answer. What I can tell you is that it's, of course, it's a bit slower than not using NIM, but it's decent. Like, I have been using my proxy for the last 4 days, and honestly, it's a bit slower, but very much tolerable. And what I can also say to you is that when we will fix those parameters, this combination of packet size and sending rate will basically define a maximum download speed, and you will be able to reach that speed in the sense that the network is actually making use of the bandwidth that we allow him to use, but it's just not set in stone yet. So stay tuned for when we will do that.
just a ballpark figure when it comes to that like target download speed that we're gonna achieve once the general purpose app for the NIM mixnet comes out. What would that be? So how do we imagine that?
Well, one option that we are considering right now is having packet size of 32 kilobytes. And if you if we keep that and the sending rate that we have right now, which is 50 packets per second, we are in the range of 13 megabits per second, which is actually a pretty good connection. So it might not be. It depends on other factors like the gateway. How is the provider doing on the other side? But basically, we can do anything between like half a megabits a second to maybe 20 megabits a second. So yeah.
I would assume that it also depends on the number of mix nodes currently on the mixnet, right? And overall network load. Is that accurate?
Yeah. Although we can easily scale the mixed nodes, like we can easily add more to it. So it's probably going to boil down to the gateway and the number of clients. I don't
Oh, and
like. I don't. Yeah, go ahead.
sorry, go ahead. No, you go ahead.
I don't think the mixed nodes will be the actual bottleneck in the end.
Another question from George. What is the reason for capping download speed? Is it to further anonymize traffic?
Yes, because well, it's not. It's not. It's more of controlled sending patterns more than a capping download speed. It's just that you want in an ideal world you want to send like let's say one packet every 20 milliseconds, whatever happened. Whether you're idle or watching, I don't know, Fast and Furious in 4K, you want to have the same pattern so that an observer would not be able to tell what you're doing. So that's the reason on having this whole sending and cover traffic strategy, which we are actually working on. It's to provide with the best unobservability that we can.
So basically, in summary, everything the mixnet does is trying to so from an outside perspective, if you train some or try to train some machine learning algorithm on what happens in the mixnet, everything looks very similar.
Yeah.
And that also includes the speed at which stuff travels through the mixnet, right? Because that would also be something that could potentially de-anonymize you if you send enough packets.
Yeah, in the ideal world, any adversary watching a part or the whole mixnet, whatever happens on mixnet, whatever it doesn't matter how many people are connected, what they are doing, the adversary should still see the exact same thing. And that's like the ultimate goal of the mixnet and that everything we do. Now we are not in this theoretical ideal world, so we're just trying to do our best to go towards this perfect anonymity.
And I guess the whole anonymity loves company argument or our motto that we like to repeat comes into play here as well, right? So
Yeah.
it's easier to achieve that when we have many thousands of actors on the NIM mixnet, so many thousands of clients, rather than just let's say 10.
Well, if we go to the extreme, just say one. Like if you're alone on the mixnet, well, who cares how you're hiding your packets, your patterns, or whatever? There's something. It's only you that is causing it. So that's why you need people to hide in, which is called the anonymity set. You need a plausible anonymity set of people to hide in. Hence the saying.
And yeah, so I mean, that anonymity set can be partly made up for by the mixnet itself through white noise and cover traffic, right? But ultimately, the true anonymity is only possible if a lot of people are using the network.
Yeah.
And then when it comes to packet sizes, because if I remember correctly, the packet size conversation came up last time we spoke too. So we've been playing around with this this value quite a bit. So what does depend on the packet size? Why is it something that we're looking at changing?
So we're trying to. It's a problem because basically the problem is that each packet size will determine an anonymity set. Like the people who are using, let's say, 2 kilobytes packets will only be anonymous among the other people that uses 2 kilobytes packet. And if someone is using 32 kilobytes, but he's the only one, well, he won't be anonymous. So at best, we want a single packet size, but then it's hard to find a one size fits all because between someone that is only like doing crypto money transaction, cryptocurrency transaction, or someone who is streaming a movie, well, it's not the same use. So we are considering considering having 2 different packet sizes, but not more. Otherwise, the anonymity set is split
Compromised.
too many times.
Mhm.
And so yeah, the challenge is to find like let's say a pretty small packet size for small transactions and small communication like chats, instant messaging and stuff. So you're not wasting your internet connection sending a lot of traffic when you're actually not using it, and having a bigger one to make bigger things like surfing the internet, downloading a movie, streaming videos, or whatever. But then, well, then you also have like reliability issue. Maybe you're pumping too much traffic into your gateway or whatever. There's just a whole bunch of problem that pops up. So it's not a trivial thing to determine.
And also, my understanding, at least, and correct me if I'm wrong, is that sending larger things such as images and even more so videos or larger stuff, right? If the packet size is larger, then that is more reliable, right? Because if I don't know, if I send an image in 1,000 pieces, then I have 1,000 pieces for the mix net to drop, or some mix node to drop. But if it's only in 10 pieces, let's say, then there's only a 10% chance of that happening.
Yes,
Right?
that's a trade-off, because if you have 1,000 pieces, of course, you will have more chance that one of them will be dropped, but you can retransmit it if this happens. But if you have only 10 pieces, your pieces are much bigger, and so you have more risks that a node somewhere in the middle, maybe on the NIM network, or maybe just simply on the internet, you have more risks than this node just drops your packet because it's too big. And if you want to retransmit a packet that is too big, it takes more time. So it's sort of a trade-off, and you want to find the middle ground, basically.
I see. And let's talk about another trade-off for a little bit, because there's also a trade-off between anonymity and latency. And you said earlier that on an average hop, the latency is about 15 milliseconds per hop. So that would be a pretty decent latency for basically any use case other than, I don't know, hardcore online FPS gaming or something, like competitive FPS gaming or something similar. But then the range within which you define the random delay that each hop adds sort of contributes to the possible anonymity achieved, right? So maybe for something like an email where you don't care a lot about whether it gets there in I don't know, a minute or a day, then it would make sense to have a range, to pick the random amount of delay that is added to the packet from a much wider range. So is it also a trade-off that we're making for lower latency versus anonymity, or how does that work?
Well, in theory, the mixes that we are using, which are continuous time mixing, in theory, the anonymity set is every packet that ever went into that mix. Because if I'm sending a packet and it comes into a mix, there's a certain delay, but the delay is on average 50 milliseconds. But the way we pick it is that it can very well be like 1 second. It's not very probable, but it's possible. And so you can, but in practice, well, it's probably not going to be 1 second. So you can, in some sort, like make your anonymity set smaller and say, okay, I'm only going to consider in the anonymity set the packets that went in half a second after my packet. And if you're increasing that delay, you can also increase that practical window, even if the theoretical window is still the whole of the package that comes out after yours. But yeah, it's as I'm explaining this, I'm realizing it's overly complicated, but
A bit. Can you please try a different way?
yeah,
Because
yeah. So let's make that simple. The way that it's working is that if I'm sending one packet to the mixnet, to one mix node, let's focus on one mix node, and it arrives at the mix node, then you're sending another packet in the same mix node. There are now two packets in the mix node, right? And if you see one coming out, basically it can be either one of them. And so if you have a longer delay, you make time for more packets to come into the mix node before yours leave. So you are basically increasing this anonymity set. But
so we can maybe call it a per mix node anonymity set, and given that all packets look the exact same from the outside, you basically hide your packet even more by allowing more packets to. Okay, that makes sense.
And then the slight trick, which makes that the actual anonymity set is more than just the packets that were in when your packet left, is that an adversary cannot tell exactly when your packet leave. So maybe it left, but maybe it's still in there, mixing with the packets that are still incoming. See what I mean?
Exactly. Yeah, I understand now. Thanks for that was a really clear explanation.
And since the delay, it's on average 50 milliseconds, but it can land in a very high value. In theory, you have no idea when your packets come out and when you can stop your anonymity set. You only have to guess stuff based on practical experience.
I see. And on this topic, actually, I hopefully I'm not oversharing, and this is not something secret, but we did talk about basically there being a slider, which people can configure the anonymity or the privacy, the level of privacy they get, and then this would basically set the range for packets, the possible range within which the delay will be picked. Is that something we were thinking about?
It's definitely something possible. It's not on the table right now, but it's something that we can definitely do. But then you just have to be careful on what you're announcing, because how do you rate anonymity in a manner that is understandable by everyone? And are we really sure that we are actually providing this level? So it's once again a tricky task to achieve, but definitely achievable.
Well, and also, I have vague memories of reading the white paper. I really need to reread it because I haven't read it in quite a few months. But I think it was mentioned in it that if the delay is too long, that's also a way in which so it will be unique to packets, to individual packets, that they have been delayed for much longer than all the others. So that could also de-anonymize or possibly compromise the privacy of the network to some degree. So it should be at least more or less homogeneous for each packet. Is that correct?
Let me
Could be wrong about that.
No, I think you're right. It comes down to the fact that when we are setting a delay, we are not setting an actual delay for every packet. That would just be dumb. But we are basically characterizing a distribution. We're basically creating probabilities of a certain delay to happen. And when I say 50 milliseconds, it's almost every time not going to be exactly 50 milliseconds. It can be 45, it can be 60, but on average it will be 50, but it can be anything else. And if you put your delay are just wildly different, then the distributions are wildly different, and you do not really you kind of lose your anonymity. Yeah, but it's God damn it! Everything is so hard to explain.
Yeah, tell me about it, man. I mean, at
But
least you know what you're talking about. I only know half of the questions that I want to ask. So
they're
we have
good
a
questions so far. So it's
thank you.
it's me who's doing a poor job at answering them.
Not at all. Don't be so hard on yourself. You're doing a great job. So then, one of the other questions that I had, which I'm super interested in. So we are going to roll out something over the year 2023, so next year, which is going to be our general purpose use case, which I'm very excited about. So it's basically quote unquote the NIM VPN, although I personally really hate the term VPN. When it like calling our tech a VPN is not doing it any favors because it's much more than that. But
No.
you know that's how people understand what we're talking about. So
Yeah.
basically, how our audience can imagine this tech, it's going to be an app just like any VPN, but so all of your traffic, it's all traffic of your machine will be routed through that app, and behind it will not be a single server, which may or may not actually protect your privacy or sell your data, but it's going to be the mixed behind it. So that's the idea. And what needs to happen before we release that? So
Um.
what's the key weak point currently that we're investigating and trying to fix?
Well, the whole I'd say the whole parameters of the mixnet, like the packet size and the sending rates, because those are two key points that will determine the speed of the network. And because right now we're using 2 kilobytes packet, which is fine for texts like Telegram or Keybase, but for a general use case, you want much more bandwidth. So that's one point, and the rest are probably in the hands of the dev team. So you'll have to ask a dev when one comes in here.
At some point I will. Nice deflection. Well done, Simon. I'm proud of you.
Well, I mean,
And look,
I'm just telling what I know. I'm not inventing stuff.
yeah, you shouldn't. You should never do that. Other than tech, if you want to invent something that improves NIM, be my guest.
Well, I'm working on that already.
Once again, very nice comeback. All right, ladies and gentlemen, with that, we actually arrived to the end of the questions that I had for Simon, the other Simon, not myself. So if anybody has any other questions, maybe regarding anything we talked about or something else, then let us know. And if not, then I am going to let you go because it's Friday and the week is over, fortunately, finally.
I think this is a great moment to share the survey.
Oh, actually, yeah, let's talk about that, Ismail. Go ahead. Take it away.
Yeah, so you're all probably familiar with NIM Connect. So we've seen some more usage of NIM Connect, and in order to make NIM Connect better and just improve everything in general surrounding NIM Connect, we've released some sort of survey today, and we've shared it in the NIM Connect survey channel. In the help channel, but I'll share a link right now. So please, if you've used NIM Connect or are using NIM Connect, please take the time. It just takes 2 minutes of your precious time to fill in some questions. It's just 4 or 5 questions that we created. And if we have a few of these submissions today or in the next few days, that will be great. So we can pass this feedback on to the team and thereby also improve NIM Connect. So I'll grab the
Exactly.
link
And
and
NIM Connect is well, I mean, the usage of NIM Connect is kind of mandatory for increasing the prize pool of Shipyard Academy. We did that on purpose because we want people to put first of all to put the mixnet under stress, which we've been doing also internally, and now it's time to max out the mixnet and see what it's capable of. That's one reason, and the other reason is because we want to improve NIM Connect itself and iron out all the bugs. So we want to onboard more people. So for that to happen, actually, Ismail just shared the link in the community call text channel. For that to happen, we need feedback. So if you have any issues, especially using NIM Connect, then please make sure to let us know. And one of the important aspects of this is that We also need to make sure that the mixnet is censorship resistant. And with MemConnect, we can also gather information about possible regions where traffic, such as traffic between clients and the mixnet, is being censored at the moment, and we can come up with solutions to that. So please fill out the form if you have any feedback for us. And with that, unless anybody has any other questions, I think I'm going to let everybody go. Huge thanks for coming on today. Also, huge thanks for you, Simon.
Well, thank you
Hope you
for
enjoyed.
inviting me again.
You'll be back. I hope. I hope you'll be back at some point in the near future.
Yeah, I'll be there in the audience if I'm not there on stage.
Oh yeah, by the way, Simon is always in the audience basically for most of these calls. So if you ever want to talk to him, then you can reach him in the community call text channel during these calls. And as always, the call was recorded. You may notice in the audience are dear recording bots, Craig and Gark, so it will be uploaded to the regular dedicated community call playlist on YouTube. Huge thanks again for everybody for joining. Have a lovely weekend, and I'm going to pass over to Ismail so that he can tell you about how to collect your POAPs for this community call.